is you want to drill a 1-inch hole through the body of the peppermill and expect it to stay centered. It's not going to happen. So what you do is this: you start with a drill bit. In this case, it's the Forstner, which is rigid, solid, and this thing will follow the center because this is rigid. Everything is rigid, so it'll follow the center. Then what happens is when you drill with this, the point is the problem because the point will follow wherever it's easy to move. So if it encounters a soft spot on the body in the wood, it'll follow that. And what happens is by the time you're done, well, the damn thing is shaking like crazy. So to do that, you eliminate that point. You eliminate that center. So you start the hole with this so that the blade drill has a path to follow. Already has a guide. Then you use a 3/8 inch drill, a long one, obviously, and you always drill towards the center. You don't drill through and through. You stop in the middle, give or take. Okay, you do that on both sides. You do the same thing. You start with this, drill with this, and then finish it with this. The reason is this: that by eliminating the material in the center, then the point doesn't have anywhere to go. It is these edges that now guide the drill. So you go right to the center. Then when it's time to turn the piece around, well, you do the same thing. And what happens if you're off? You're probably off, but maybe 64th, 32nd at worst. So it's not bad. So if you're doing this one here is going to be a 10-inch one, okay? But if you're doing a 12-inch or up, that is the only way to do it. We made with Gary, we made a 24-inch, and it works beautifully. Obviously, this requires an extension because it's too short. But again, towards the center, and you do that on both sides. It works beautifully because now it is the edges of the spade drill that is used to guide the drill forward. The center is no longer affected by the point because there's no material there. Okay?
Why not go all the way with the Forstner?
They're usually very short. I wouldn't try it because nevertheless, at that distance, it can. Which one? This one here? Oh, I agree. But this, well, no, the Forstner, it's got lots of room to come out. Things you always try not to force the issues. Okay, so it's always better to be how do you say, more cautious than brutal. So the thing about going right through to the other side, there's no guarantee that you're going to be exactly dead on. So what happens is if you attempt to do that and your hole is not centered, well, how do you then adjust for centering the whole thing? So the idea is you center. If there's an offset, it'll be inside the hole, and it won't affect anything. But at least you have the two ends which are centered that you could use to mount to center the object. Okay. Now I was handed these things to do a peppermill, and there's no instructions. So I didn't know exactly how to go about it, except I took measurements of all the parts, and I came up with this. So now what I'm going to do, I'm going to follow the drawing. As I had mentioned before in the past when I made some candlestick holders, you always start with the drawing. If you have a drawing, then you can make as many as you want because you're following instructions through the drawing. Remember the expression, you make one and it's hard to make the second? Same thing? Well, not if you start with the drawing. If you have the drawing, you have that to guide yourself. And if you can make one, you can make a dozen. Okay? So that's what I'm going to do. So to start with, what I'm going to do is I'm going to make the two cylindrical, remove all the corners, and we'll proceed from there. Okay? Yeah. What I'm going to do is I'm going to start with the head piece. The reason is that by doing the head piece first, then the parts that actually come in contact with the main body, I could then use this to check to see if my hole is correct. Okay, so it's not a. That's the only reason. There's no other. There's no other explanation. Okay. Yeah. Now, I know that this is the dovetail chuck or jaws, but I'm only interested in making sure that this thing is centered. We don't care if it. I don't care if it pinches. I don't care if it pinches the wood because I I'm going to remove that material anyway. So basically, I'm pinching the ends because the jaws are not. Something else also I want to point out before I continue is that I always want to finish my Peppermills. How do you say end point to end point? No chucks. So I have to prepare both the body and the head piece that rotate so that I can then hold them from each end. So what I do is I make myself a guide, which basically is a dovetail tenon, okay, and this piece is going to be used for centering my the body because the bottom hole is going to be that size. So I'll have this also to guide me as to the correct size so that once it's done, when I put it into the chuck, it will be centered. And the other end, which is this piece, I'm going to have a hole already in there, which I'm going to do just about now. And I made myself also the same thing. This pin goes into the hole, and the center point is going to be pushed by this. So the pressure of the tailstock against the two parts will keep it in place for me to finish it. So basically, the finishing is between centers. I can remove this part here and replace it with a drill. I designed the guts inside based on the parts. Outside, whatever you like. In this case, I made it a very simple design, straightforward, nothing fancy, nothing great. But I chose the size so that it's for us guys that we have big, relatively larger hands. I want it to be comfortable. So I made the body and the head large enough so that it's easy for us to turn. Again, it's a choice. There's no written rule. This is going to be more like a touch and go because I don't want to go too deep for every pass. I already have my center. Oh, this one does not require the big Forstner bit. This one is basically the top. I only need the hole for the stem. Okay, that's what I'm doing now. Okay, let's take this out. Now once I've done about an inch or so, then I don't want to keep turning this every time. So normally what I do is I take this out, I just go. Okay, so that's done. Let's look at the drawing. Okay, this requires a roughly half inch from here. Do we see that? Okay. It's half inch step, and the diameter is 3/4, not 1 inch diameter to fit the body. Okay, so let's get the calipers. Now, when we this is the part that is the actual mechanism. So accuracies are important. The shape, no problem, but the internal guts that hooks up with the main mechanism has to be correct. And we're going for 1 inch. Okay, it's the inner one. Okay. Almost there. Okay. Now this at this point is really not that critical, the actual size, because then when I make the hole for the main body, I adapt the hole to this. So I'll do as best I can to get close, but I'm not gonna go nuts. And so as long as it's slightly bigger than 1 inch, which is the destined hole. If it's a little bit bigger, then you just shave off a bit on the other one and make this fit. All this is because I do not want this little stem I don't want this stem to determine the, keeping the whole thing centered. It's too flimsy. I want this body to keep it centered. I'm gonna check to see if it's straight. How about that? What a fluke! It's a fluke. Now in the center of this, what do you call it? What do you call this? Tenon. At the center, there's also a slight indentation or a slight recess, 3/4 inch, to accommodate that the part that gets screwed on. Okay. Get 3/4. Right on. How about that? So I gotta go a little deeper. All this is to accommodate this, and I'm a little bit too big in the size. It doesn't matter. Okay, so we're good. Pardon me? Well, it's a part that has the slot that allows the stem to go in, so then you could actually drive the stem to turn the grinder. Otherwise, if it's round, then it won't move. What I will do now is I will do a very quick sanding job and then seal it so that it'll be done. The reason why I'm doing it is because once I take it out of the lathe, this one I cannot put it back. So I like to be able to finish it on the spot. Okay. I do all the shaping at the end. I do only the part that is all the mechanism. That has to be done correctly so that the mechanical parts fit correctly. Once that is done, then the outside is just a matter of shaping it the way you want it to shape. It's your choice. So for small surfaces like that, I can actually increase the speed to finish it off, and I really don't even need I don't need any accelerator. Now we work on the body. Whenever you're doing a job, mark your centers. if you know that you will be going back, then you better don't forget it. But if you're not sure, you mark it. You never know. You may need to. Now I'm using this strictly to center my piece. Okay. Now the finished diameter at the highest points is going to be 2 3/4. So this is 3 inch diameter right now. So I have enough room for this to get pinched without affecting the finished turning. Okay. So now it's there. So approximately the center here, past the center is fine. See, I can go in up to here. So I have at least that much as a guide. And because the Forstner bit has a pin at the center, that gives me the starting point for this drill. I I don't have to go this deep. I'll just stop right here. I have enough material to guide me. Okay, that's far enough. Okay, now for the spade. But here's past the center, so it would be right here. Wait. Something's okay. I think it's my drill bit is probably not straight. As you can see, there's nothing vibrating here. Okay, that's fair enough. Now this is going to be the part that I will be making as the base, the bottom. The top is there. Okay, so this is the part I have to. Now there's a little step in there. Probably a different size. So I'm gonna go in a bit more. purposely will see if I can remove it. I'm not sure. It's not critical, but no, I can't. Okay. It's got too big. It is too big. It's not to my liking. It's supposed to be 1 inch. Should I? Is this correct? Yeah, this is 1 inch. Yeah, so it fine, which means on the other one I have to be a bit more careful. Okay. So let's look at the drawing. Okay, so the outer hole is 1.46. Okay, let's use a pencil as a mark. First of all, I'm going to remove this wobble. There's a little wobble there. Okay. Too big, it's fine. That's way too big. Okay, over here I am about right. Okay, so at least I have a guide. Perfect. Very good. I have to go 1/4 inch deep. So let's up by 1/4 inch. Okay. This is right. Okay, so this is done. Now the next one should be 1.275. This is the, how do you say, the boring part, but you gotta do it, you gotta measure it. done. Okay, so I have to be at 156 deep. Yes, we're good. Okay, so let's finish this off. Let me check with this. Perfect. Okay, done. Now let's turn it around and we'll do the other end. And for a pepper mill, one of the biggest problems is that you have to drill right through the other side. And drill bits will never keep the path. They'll always deviate from the center. So what I found is that number one, you drill from each side instead. To do that, you make sure that each side has been marked. So you turn your cylinder, center to center, okay? And this way you are lined up with the center. Then when you're ready to go, you put it in. You make sure it's centered correctly. And to make sure that the hole is lined up, you drill from each end. But the way I do it is I start with. And by the way, may I just explain from what happened last week? Remember when the hole was too big? Wrong bloody drill. I brought the wrong drill. I should have measured it. You see, it was 1 1/8. Okay, so we're going to do 1 inch this time. So the idea is you use the Forstner bit to get your starting direction. Why? This thing does not deviate because it's rigid, it's short, plus it has the two sides that act as a guide. So I can go as far as I can with this, and then I drill the center out with this. In other words, I remove material from the center of the wood, so that then I finish the job using a spade drill. So the point does not have any wood in which it can deviate. Okay, it's the sides now that drive the drill straight. And we've done one with Gary. We did one that's 24 inches long. So in this one last week, I went up to here roughly. I did the work that I had to do for the mechanism. Now the rest is just for the part that you rotate. If you want to maybe look at the drawing again for those who were not here. So I was given the mechanism without any instructions. So what I did is I took the mechanism. Well, I measured each part, and I end up with this type of drawing. Now, as far as the outside is concerned, that's typical of a mill. It could be round. You could have beads. You could have whatever. That's strictly to the person's desire. But the mechanism has to be correct. So that's the one that you have to make sure it's done correct. So I've done this part here. Okay. Now we're going to have to do this part here. Okay. Now what happened last week is that this part was too big. So I chose that side to do the back. Okay. Now I have the right bits. Okay. Okay. So we're going to start by drilling the guide. I call it the guide because it's not really the final part. I'm going to go as far as I can, and then I'll drill the rest. Okay. It's not supposed to fit. This is tight. Okay. I say it's not supposed to fit because I want to tweak myself right to the proper size afterwards. Okay, here we go. It's probably a little too fast though. Okay, give the drill bit a break because it gets very hot. Okay, that should be enough. Okay, then we'll change for the drill bit, the long one, to go through. The other thing is that once we start the drill with the Forstner bit, the center inside here, the center is marked. So this will start at the center. I always feel the drill to see if it's wobbling. In this case, I like it. It's really smooth, not wobbling at all. There's no wobbling. Good. Now we'll see afterwards when we take it out of the lathe. Sometimes I actually see the disc inside where the two meet, and you have the disc left over, and that gives you that tells you how good or how bad it is. But in any case, it's in the middles here somewhere. If there's an offset, who cares? The Peppers doesn't care. Okay, so this is done. Now I'll check to see whether this is square. Now what we're going to do is we're going to widen the hole so that this part fits in with a little bit of play so that we're able to rotate without a problem. This is a little bit you call it a touch and go. So you have to be careful so that I don't remove too much material. Okay, that's where we stand. It's just, I'd say just right. I have the movement, but it's tight in the front, which means I need to remove just a bit material in the front only. Perfect. So what I'm going to do is this part here, there's going to be movement that's going to happen. So I'm going to just sand it down really smooth up to maybe 400 and then seal it with CA. So it gives you a nice hard surface. In a pepper mill, these are all the important steps because here we're still looking at the mechanism, the mechanics of it. So it's got to be done right. Once that is done, the outside is just, you like it round, make it round. You like it bobbly, you make it wobbly. It's totally up to you. Okay, we're looking at maybe half an inch or so. Now at home, what I did, I made myself a sanding uh, cylinder, if you like, where I could actually, with a stem about this long, I put it in the drill and just go, you know, clean up the inside because the inside comes off always a little bit rough because of the scraping. Okay, so right now I'm not going to do that, but that's what we could do. So let's apply a little bit of CA here, and it absorbed very quickly. Apply the first coat. First coat, I try to apply it by hand because you're just sliding the material across. If you make it rotate, it heats up. It heats up faster, and it doesn't give you much time to work. So I'll give it one more film. Okay, do this as well, and I will use a 600 to make sure that it is cured, if you like. I got some stuff. Here we go. I check to see that I haven't increased or decreased the diameter. We're good. See, there's no play. It's smooth, but there's no play. Okay, I got one more coat, but this one I will do rotating because the first coat gets absorbed very fast. The second coat goes easy because it's only on the surface. I'm not putting any inside because I don't need to. The friction is here, not on the inside. Okay. It's the first and the last sanding. Well, I won't do any sanding. After I shaped it, it'll be done. So the sanding I'll do at home. So basically, at this point in time, I've done the mechanism portion. So what I do is I take this out of the lathe. So I had made a guide for both sides. One has to be for where the mechanism is, and the other one is where the headstock is. But this particular model has a shaft that goes right through to the other side. So I could not use the original, not the original, my other technique of putting it, together. I'm going to use it center to center to turn. So therefore, I need something to put in the hole on both sides. Well, here and here. Now I cannot use this direct because the tailstock is smaller than the hole, so I got play. So to make sure that doesn't happen, I make sure I have a support. Okay, so now that's that. This goes on this. I always move like this, make sure that it sits right. And then I check to see that it's centered, which it is. Okay, and for the other part, I made a pin that fits into the hole here. Okay, so now we could hold it between centers. So just the pressure of the two pieces against it, it's enough to hold the piece in place. So now the question is, how do we shape it? Well, on the drawing, I measured distances from the bottom here all the way up to the top, and I just mark where they go, and then I also have the depth that they have to go to. This way, I just go with the parting tool in there, and I just follow those lines. So I'm going to start by simply marking those points. They're all at 1 inch intervals, but it starts at 3 1/4. No, 2 1/4. 2 1/4, and then it goes 3 1/4, 4 1/4, blah blah blah, all in the same direction. 2 1/4, 3 1/4. 4 1/4. Okay, 7 1/4 right here, and then finally the last one is at okay, this mark here is one of the intervals as well, and the center here is at 2 1/2 from the joint, right here. It's a very simple design. Everything is all straight lines except here there's a curve. Okay. Now, okay, so the first one, which is this line here, 2 3/4. So I set my my calipers to 2 3/4. There's one thing I'd like to mention as I go along is that you have to look at the curvature and see where the cutting edge of the scraper, no, the parting tool should be. Okay, let me give you a quick explanation for as what I mean. Okay, now the curve goes this way, right? Okay, now it means that you always put the cutting point and at the highest point of the curve. So if I'm cutting here, for example, I'll put my left hand cutting edge on the line. And as the curve goes downwards, I use the same cutting edge on the line, okay? Because this has a certain width. So if you use it in the middle, you're removing more material than you have to. So then as you change direction, as it starts to go up again here, then you use the opposite side. We're about there. next one would be here, would be at 2.25. Okay. The next one was at 1.882. Next one is on 1.652. Next one is at 1.559. Now this one on 1.559, it's pretty well where the changes direction. So that will go, I will go right in the middle of the line. Okay. And 1.601. So now it's bigger. So now I'll use my right hand point. That's it. And finally, 1.601 is done. And the last point is 1.633, just a bit bigger. Okay, done. And this should be at 2.75, the same as the bottom. Okay, done. I want to double check if my distance here is still 10. Yeah, that's right, the edge here should be 10. move too fast. Okay, that's so at this point in time, all I'm doing now is just watching, see if I can make this curve as uniform and as smooth as I can. Okay, the joint is right there. Gotta check, make sure I have my 10 inches over here. That's important because the stem has to come through here. I gave it about a 1/4 inch, so I want to make sure that the stem goes through and not too far. goes too far out, then I have to start using washers in between. Let's verify. Okay, 10 inches is past this curve, which is fine because this is not the end point. The end point is somewhere in the middle. So I have to sort of go into this block here. Okay, I'm going to stop at this point. It's pretty well done. The rest is sanding. The end point is right here, right there. That's the end point right there. So whatever wood is left over there, I'll sand it down. Just give it the final touch. Because if I can go any deeper, I risk, losing my pressure. So basically, this is it. It's a matter of rounding off any corners that may not be round. I can give it a little curvature here. Wrong way. See, the stem reaches about right here, which is exactly where I want it. Okay, so once I clear that out, the knob, or if you call it the nut, will be able to fit. Okay, so very simple design, nothing spectacular. I thought it was using smooth curves, and that's it.